Hey everyone, good morning. Oh, sorry, good evening. This is Rishabh here. I'm audible?
Yeah,
Right, thank you. Let's wait for others for a couple of minutes, then we can start the session. And I hope my screen is visible to all of you who all are there in the call.
yeah.
Great. Let's give them one more minute, then we can start. Cool, let's start the session. Everyone, how are you guys? All good? Anyone?
Yeah,
Yeah,
good.
yeah, I want to keep this session interactive, right? So we all are learning here, right? So I'm going to teach you everything related to statistics in this course that is required for data science. We'll start with our introductions, right? So, hey all, I'm Rishabh Gupta. I'm a data scientist in a retail firm, right? And I have like approximately 5 years of teaching experience and approximately 7 years of experience in data science. So day to day, I play with statistics, work on GenAI use cases, a lot of deep learning and machine learning use cases as well. So I've worked in, two, three domains, mainly in finance and retail, and statistics is required everywhere. Trust me. So, like it's a part of our daily life. You will find statistics everywhere. Yeah, so it's a good thing to learn. So let's start with your short introductions. I think we are like very limited here, so we can, hear everyone. Who wanna go ahead first?
Yeah, hi, myself, Kumar. Have total 6 years of experience in quality analyst, and currently I'm dealing with the data migration stuff. And I'm belongs to this. I'm working with Oracle DB from few years, and along with that, I have little exposure to TDM tools which generate synthetic data for real-time use or practice. I mean, to create models in ETL environments. Yeah, this is all about myself. Thank you, Rishabh.
Thanks, Vinay. Next. Okay, Ashish, you have just started in data science. Cool. Anyone else who wants to introduce yourself? Okay. Okay, so let's start with the session then if you guys are not interested in the introduction. But as I said, I want to keep this interactive, right? I don't want it to be a boring session. I want your points, right? What do you think about the topic that we are learning, right? And we'll have a couple of quizzes and exercises during the session and even at home as well, like kind of homework, right? So what is statistics, right? uh, you know I think most of you are unaware about this topic. Like as you said, you guys are new to this, right? So let's start with a very, very, very basic thing. What is statistics, right? So anyone have very minor idea what it is? You can paste it in chat if you don't. You're not comfortable to speak, right? I can read your chats. It's fine.
Mm,
Okay.
yeah, I have little idea about statistics, like which can be descriptive or analytical purpose, which we can derive like a future prediction as such, or else analyzing the records or previous records to estimate the future. I mean, the current things or analyzing purposes to find the bell curves and distributions, how it is happening, and correlations of the data and how it is working and how it will work in future as such. So
Very nice. Yeah. So in short, you have covered almost everything about statistics, right? Uh, but I'm gonna give you all a very basic definition of statistics, right? We will not, jump to into the big term, big jargons directly, right? So it's basically a science of collecting, organizing, analyzing, interpreting, and presenting your data, right? So all these terms are very helpful. We start with the data collection, right? If we if you're let's like if we are work we if we are going to work on a use case, right? So the first thing that you're going to do is to collect the data, right? Because data is the most important thing for any statistical or ML related problem. So that will be your first step. So it's the science of collecting the data, right? After collection, right? So now you have to organize it as well, right? So that will be your next step. So again, it's the science of organizing as well, right? Now the third step will be, you will be analyzing your data, right? After the, after collecting it, after organizing, after collecting, organizing. Now what you will do, you will start organizing your data. All these terms will be visible on my display as well. If it is not visible to any one of you, please let me know. Okay. After analyzing, what we will do, the next step is going to be the interpreting, right? You have done all your analysis, right? We will get in the detail of all these things, what all are these terms in detail, right? In our next sessions. Today we will talk about purely the importance of statistics, what it is and how are we going to use it, and the basic terminologies that we use in statistics. And let me know if it is the pace is slow or pace is very high, you are not understanding anything, you can interrupt me anytime. Okay. Try to keep the conversation mainly in chat, right? If you want to discuss something, then unmute yourself and talk to me. All good? Yeah. So we were at the interpreting part of it. So after analyzing, what you will do, you'll be interpreting your data, right? Finally, after interpreting, now you want to share it with your colleagues, with your business partners, right? Or to your, if you are in college, to your professors, or maybe in a class presentation, right? So you will be presenting the data as well, right? So how will you do it? So we have graphs, right? Different types of graphs, right? So in those graphs, we can put our data set. There could be count plot, an histogram, right? That kind of graphs we can use for our analysis part of it, right? So now why we do this, right? So the second part is because it helps us in making data driven decisions, right? So let's say I ask you a question, right? How many, what is the average age of your class or, of your office, right? So what will you do? You will just take a sample or maybe the whole population. We will talk about all these terms as well. What is a population? What is a sample, right? Generally, what we will do, we will, take the whole record, right? Take the age of all the employees or all the class, students, and then basically average it, right? That is one of the methods. So if I just want to know about the average age, average height, right? These are very basic examples that I'm taking, but we'll be dealing with the difficult examples as well in the later session of the classes. Okay. Any questions so far? Anyone? Okay, great. Cool. So why statistics is important for data science, right? I think I've already explained some of the terms, right, in the first sentence itself, right? So, one of you can tell me with the limited knowledge that you have, right, why it is important for data science. Anyone? Okay. See, one thing, let me tell you, right? If you keep it interactive,
Yeah.
right, you
Like,
will be engaged and you will not feel bored in the session because starting in like will be theory, right? When we'll be doing experiments, you will feel entertained, right? But in the start, you will be having a lot of theory. So it's better if we, have some communication.
yeah, like statistics, why it is important means generally we have vast of data which might contain millions of records. So to find a particular data which replicate the entire structure of it, and to analyze based on that, statistics is must and should we, I mean, we should have an idea and we should use those concepts while predictions of it.
Okay, great.
Thank you.
Yeah. Okay. So thank you. So thanks for the explanation. But as I told you, like I'll be going in the not in very detail, but we'll start with the easy things, right? So as when I mentioned, like there are a lot of things that we can do, but we will understand it with the very simple examples, right? So I've given you few examples, right? I just want to extract meaningful insights from your data, right? We took example of your class age, right? Class height, or maybe the average age of employees, average salary, right? So these are the very basic insights that you can gather from the data, right? Uh, let's say you want to produce some t-shirts, right, for a very large population. So what insights you will gather, right? So first of all, you will see what is the age group in that population, right? So according to the age group, you can decide, okay, how many of them could be, XS size, S size, M, L, and so on, right? So that's how we, analyze the data and try to come up with the meaningful insights for our business use cases, right? Second important thing is it supports predictive modeling and machine learning. So when you start working on those use cases, right, you will have to deal with a lot of data sets, right? And in every data set you will find a lot of problems, maybe some like there will be a lot of missing values, right? And sometimes you'll be creating new features. For that you can use your statistical methods, right? So there are a number of things that are even important for our predictive modeling and machine learning use cases, right? And the most important thing, if we keep these things aside, predictive modeling and machine learning, only statistics helps business to make decisions, right? Especially in healthcare and social sciences or businesses, right, where we take decisions based on just statistics, right? Like if we talk about like 15 years before only, we were not using any machine learning, any big machine learning model. Most of the models were based on pure statistics, right? Okay, now let's talk about some real world application of statistics, right? Where in business we use this, where in healthcare we use this, technology, social sciences, right? So in business, like as I've given you an example of the t-shirt production, right? So for that you will be doing some market research, right? You will be trying to find out the age group. Uh, First of all, the most important thing is the age group here. For at each age group, then you'll be checking the average height there, right? Average size. It could be, based on the obesity, a lot of things, right? So that's how we do market research for our business. So it's one of the important thing, to do to solve the business use cases, right? The next good example is customer segmentation. So as I mentioned in the last use case only, the market research, right? Whatever we were doing, trying to put uh, customers in one age bracket, one height bracket. So that is nothing but we are doing the customer segmentation part of it, right? And sales forecasting. Now again, okay, so let's say you came up with the idea, okay, these many t-shirts I should produce for this year. Okay, what about the next year? What about the year after that year, right? So if you want to get that number, right, you will be doing the forecasting, sales forecasting for that. Even for those use cases, we'll use statistics in our real life, right? We'll be covering all these use cases in the upcoming machine learning classes, right? Not in statistics, because all these involves a lot of big algorithms, right? So similarly in healthcare, we use it for clinical trials. Here we, generally use our hypothesis testing methods that we'll be covering in our statistics classes, right? Disease predictions, epidemiology, right? And again, for technology like AI/ML algorithms, we must have heard about of linear regression, right? It's a very classic algorithm in ML, right? And trust me, it's pure statistics. Okay. And even in social sciences, we do population studies, behavioral analysis, right? So these kind of things we will be studying, right? And like we'll be using statistics for all these use cases. Any questions so far? Anyone? Okay, great. So let me show you a real world example, right? Uh, so let's go ahead with a very, very, common example that we all are aware of, right? So most of you like will be aware of how the COVID-19 trend analysis. So there was a dashboard that an organization was publishing for everyone, right? All of you are aware about the dashboard, worldometers.info. Okay. It'll be great if you can unmute yourself sometime and let me know, because I'll not be checking the text messages every time. Okay, so this is a real world example of statistics, right? Where what they have done, they have gathered the data of all the coronavirus cases, right? So these were the total number of cases, right, in the whole world, right? So even they have done the segmentation by country. If we click on view by country, right? So you will see it country wide as well. Okay, it's not coming. Just give me a second. Yeah, here if you see, we have the total according to the country as well. So total cases in USA, total deaths in USA, total recovered, right? So all these are nothing but the statistics of the coronavirus cases. Okay. Let me show you a few more things, right? So here we have some graphs, right? As I was telling you, after analyzing, so what they have done here, right? They have collected the data, they have organized it, right? Like they have organized it country wise, right? Even they have the subcontinents as well, like Europe, North America, Asia, South America, Africa, Oceania, right? So this is basically organizing of the data, right? The third thing that they have done here, so now here they are not analyzing and interpreting. I mean, we can analyze and interpret just by the presentation of this data. You must have remember, like I mentioned a term, right? Presenting, right? So here they are presenting it graphically. Okay. So what they have done, so data wise, they have presented the number of cases here, right? So this is for the whole country, so for the whole world, right? If you see, if you hover on top of it, it will show you the daily cases for that particular date. So here, if you can see my screen, right, this is for November 7th, 2020, and the daily cases for 6 lakh something, right? So that's how they like we represent our data for better analysis, better interpretation, right? If we want to share it with the business or any stakeholder, right? This is the process, right? So this was the daily. It's kind of a right daily kind of a graph, right? Now we want to like see the example of one more type of graph, right? So here, what anyone can tell me what is happening here? What kind of data we are representing by just seeing at this graph?
A number of cases based on year and month and how many it was total.
Correct. So it is the total number of cases, right? Day wise. So here what we have done, we were just showing the cases for that particular day, right? But here what is happening? We are adding, right? So at this date, at this date, 5th of March 2022, how many cases are there so far in the world, right? Anyone? Any doubt? Okay, cool, no doubt. Cool, let's go ahead. Okay. Similarly, we have the graph for daily deaths as well, linear, logarithmic. I'll explain, etc. I'll try to understand, right? So let's go back to our PPT. Yeah. So now I want you to come up with a use case according to your field of interest, right? You must be, some of you are working, some of you are studying, right? So can you come up with a use case where you can use statistics? I just want to, do some brainstorming exercise here. I want to understand like, how much you understand so far. So one by one, you can start or you can put it in chat, whichever method you prefer.
Sorry, I missed it.
Yeah. So what I was trying to say, I want all of you to come up with a use case where you can use statistics, right? It should be from your the field of interest, right? Maybe from your office, right? You use a lot of data set. Maybe from your class, right? Any use case that you're working on, anything you can think of, right? I just want to test how much you learned so far, right?
Like, you want us to explain with the example or just what
No, no, no
thought?
need to explain it. Just come up with some example, right, where you can use statistics, or you can make group of 2 or 3 students and come up with an example. Yeah, Rakesh, we can analyze the data from the past data, but what kind of past data, right? So I want
Stop.
an example, any topic, right? I've given you an example of this COVID-19, right? So you can come up with something.
Analysis based on a particular form, how it was, past, and how is it growing or decaying and such.
Very nice example, Vinay. Yeah. Anyone else? Okay. So I'll give you 1, 2 more minutes to think of and to come up with some examples. Justin, Rakesh, you can, unmute yourself and tell me about the use case. So see, it's not just a class, right? I want you to improve your, personal, it's kind of a personality development as well. If you, talk to me, right, you can, you will start explaining it to the others as well, right? Because statistics is not just writing it on a paper or solving it on a notebook, right? Or some code. You have to present it in the future. If you are working on a statistical use case, right, you'll be sharing it with someone, and let's say he doesn't know anything, he cannot understand the graphs, you will have to present it to the guy, right? So it's better unmute yourself and tell me. I'm telling you it from my experience as a data scientist. It's my day-to-day job. Rakesh, do you wanna unmute yourself and explain?
Sir, we can use statistic in for the weather forecasting also, like to analyze the past weather pattern and to predict the future climate changes.
Correct. Very nice example, Shant. Anyone else?
Sir, can I give one more?
Yeah, yeah, please go ahead. As many as
Yeah,
possible.
like for the marketing and sales also we can use, for business to use statistic model, like for the future, what sell, estimate the future sales and all, right?
Mhm.
We can analyze the data and predict what could be the future sales.
Yeah, nice example. Okay, so we are 8 here, and I just received, got only 2, 3 examples. I want some more if you can give me.
Hello.
Yeah, Rakesh, I can hear you. Tell me.
Sir, we can use the data statistics here, business and finance, education, environmental science, and social science. We can use in sports also, sir, like past data
Mm-hmm.
to predict how the performance was going.
Okay. So great, all of you. Now I have one more exercise for all of you. Okay. So, like, I think you heard about three, four use cases, right? So I just want you to write one particular statistical analysis that you will do for your idea. Okay, one particular analysis, but in little detail. Okay, like what you will try to find out. So let's say when I took the example of stock market forecasting, right? So like it'll be there are a lot of things, right, that you can do for that. So I just want you to come up with one particular example, right? It should not be a very, classical example or very big example. Can be anything, mean, median, anything that you know of or that you have understood so far. You have 3 minutes. You can start writing in the chat.
Like, you want us to tell about mean median mode in terms of it, Rishabh? Like,
We will
where?
come to that. I just want you to, tell me any particular statistics that you will apply to your use case. Anything. Like you, one of some of you mentioned, right? You will do the analysis of business or stocks market, right? So what you will analyze there? I just want to know that particular one particular example out of that use case. So Ashish has mentioned here, it's I see one person, what is the chance he is basketball player given height if basketball plays 185 centimeters. Yeah, so based on the height statistics, right? It's a very nice idea to judge is he a basketball player or not. So first of all, he should, so it's like future part of it, but first of all, he should, fall into the sports person population, right? He should be part of a sports group. He should be a sports person, right? Then we can do this as an analysis based on his height, what category of sports he belongs to. There could be a number of other features to determine it, but yeah, it's a good example. Others can write as well.
Like product sales based on the percentage of offers.
Yeah, it's a very good example.
Like cloth branding brands can predict like winter coat demand or any winter product based on the weather forecast.
Okay, great. Okay, great. Let's move ahead to the next slide. Okay, so yeah, so we talked a lot about the terminologies, right, that we were using in our examples. Okay, so now let's come to let's start discussing those terminologies here, right? So we talk a lot about, problem statements, right, where we were targeting a complete set of people, right? So as I mentioned, like we talk a lot about of customers, like we were taking example of like what kind of clothes we can sell, right? So all kind of customers will fall in a sort of population, right? So population is a big soup, or I think most of you are familiar with sets, right? If you are not, you can mention it in the chat. I'll just take few examples and try to explain. Okay. I'll take a pause of 1 minute. Okay. Meanwhile, others can write as well. Okay, I guess all of you are familiar with the sets, right? So yeah, so let's start with the first term that is very, very important for our statistical analysis or a use case, right? So what is a population here, right? So population basically represents the entire group, right? That we, want to study about. So let's take the take very easy examples, that is customers, right? So now we want to understand about the behavior of customers, right? So you will have a superset of customers. Like you'll be having customers who wants one particular brand, who wants who wants three, four types of brands, or maybe like they just purchase sports products, right? They purchase sports shoes only, or some of them purchase formal shoes, right? So these kind of things you will be having in your population, right? Or you can take example of, instead of customers, like one of you take the example of a sports person, like a basketball player, right? So in the population, you will be having all type of sports person, whether it is cricket, basketball, anything, right? Because we are talking about a very big class, that is sports person, right? Now you want to like, because you will not be solving everything in one shot, right? So and you will not be able to gather all the data. So let's say if I want you to ask, right, can you tell me about all the sports person in the country? Is it possible? Yeah, good example, Rakesh. Population is entire CSE branch, right? Ensemble means CSE MS. Yeah. So correct. So well, the question was, will you be able to, collect the data of everyone in the in the population set? I think it's highly unlikely, right? If I ask you to count all the sports person in the world, right? Could be your gully cricket boys, anything, right? So it's little difficult to collect all the data for a population set, right? But to solve that problem, what we do, we try to find out a subset of the population, right? So and we use that subset for our analysis, right? So there are a lot of nuances behind the sample, right? How will you decide that this sample is perfect for your analysis or not, right? So again, there are some terms like there should not be any cherry picking, right? There should not be any bias, right? We all discuss, like we will discuss everything, right? We will discuss about cherry picking, we will discuss about the bias in the data, right? But I'll give you some examples, like in brief only. So the cherry picking is like so we'll go ahead with the sports person example only. Let's say I have a population of all these sports person. Okay. Now I wanna see the height of the players, right? And and in the each sports group. Okay, this is my problem statement. Okay, and I want to compare it as well later, right? So let's say if I'm picking only the tall guys in the basketball group, from the basketball group, average height guys from the cricket subset, right? And so on. It could be anything, right? So what I have done some cherry picking here. I've taken the tallest players in the basketball group, right? So what is happening here? You are adding bias in your data. So if you take the average height of all the basketball player, in that subset, you will be having only the tall players, right? So let's say everyone was above 6 feet, right? So your average will be around 6 feet only, right? So it means if I ask you from based on this analysis, what is the average height of basketball players, right? So what you will say based on this analysis, 6 feet. But this is not true, because what you have done, you have taken the subset or the sample based on cherry picking, or because of that you have introduced some bias there, right? So according to this analysis, you'll be having the tallest player in the basketball only, right? So this is wrong. These kind of things we should ignore, right? While trying to create a sample, right? So sample connections should be random, right? So whenever you are trying to pick a sample or a subset of your superset, you will be picking it randomly. You will not, have any bias, right? And later, after collecting or creating that sample, there are n number of algorithms that helps us to test, right? Is this the right sample for my analysis or not, right? So that will be doing in our inferential statistics science. Right now, okay, let's talk about, like, we have few more terms, but what is parameter and what is statistic, right? Okay, so let me ask you, like, is there any question so far? When we discuss population and sample, have you guys understood what is the population and what is the sample? Okay, so can any one of you give me an example of a population and a sample out of it? Anyone? Vinay, Prashant, Rakesh.
Like a number of sales of cars and the number of cars chosen by employees, like any customers, like red or based on colors.
Okay, great. Anyone else who can give me an example?
Like for the population, maybe we can take all diabetic patients in our country, and the sample is like 1,000 2,000 diabetic patients usually.
Okay, cool, nice, cool. Okay, yeah. So let's move to the next part. So here we have parameter and statistics, right? So what is a parameter here and what is statistics, right? So parameter basically represents, you know, a numerical measure measured for your entire population, right? So let's say out of the population, let's take example of cars only, right? So you have a population of cars. So if I'm asking what is the average length of all the cars, right? So let's say average is coming out around 4.5 or 4, okay? But if I'm picking a particular segment, let's say Creta, okay, so then I'll call this as a statistics, because I'm talking about a particular sample here, and that sample, that numerical measure will represent that statistic of that particular sample, right? You got it right. What we are trying to tell here, parameter is basically telling you about the entire population. If I'm talking about the average length of a car, right? So it's general, we are talking about all the cars. Okay, but if I'm saying the average length of Creta is 4 meter, right? Or average length of Hyundai car is 4 meter. Okay, then we are talking about a particular statistic, because here we are talking about a sample, that is the brand Hyundai. Okay, all of you understood?
Yeah.
Great. Okay, so now let's come to the very, very important part of the statistics. Now, like, how will you interpret your data, right? There are different types of variables that we have in the data, right? So, like, in general, there are only two types, qualitative and quantitative, right? So qualitative is nothing. Generally, in a machine learning terminology, we call it as a categorical data. Okay, so in categorical data, we call about the descriptive of the data. So let's say if we are talking about gender, so it's a binary form of data, right? You'll be having male or female, right? We have other classes as well, transgenders and etc. But generally, we talk about male and female, correct? Uh, colors, right? Let's say you have a set of color, but these things are limited, right? And they don't have any, values related to themselves. Okay, or you can talk about rating, right? 1 2 3 4 5, right? So these are looking numerical, but these are not numerical values, right? It's just a categorical information. One means very bad and five means very good rating, correct? Similarly, we have numerical data that is basically a measurable quantity of anything, right? So let's say I'm saying I'm 30 years old, so my age is 30, right? It's a measurable quantity. And if we, take, okay, let me tell you a very good thing about these two categories, okay? So in case of categorical, you will not be able to calculate any numerical statistic. Like, let's say if I'm asking you to calculate the average of colors, will it be possible? Can you anyone answer? Can you calculate the average of colors?
Oh, sorry, I missed show.
Yeah, so here we were talking about the difference between a categorical and a numerical data. Okay, so the question was, as I mentioned, categorical is nothing but a descriptive about the data, right? Let's say we talk about gender, male, female, we talk about colors, right? We talk about days, Monday, Tuesday, Wednesday, right? So these are like descriptive data and the categorical data that we have, right?
Yeah, yeah, got it.
And in numerical, we'll be having the numerical values like age, income, weight.
Mhm.
So the question
Mhm.
was, will you be able to calculate any numerical statistic for your categorical data?
Like number of colors and just we can distinct like with the like available colors we can count it, but measurable in terms of it.
Yeah. So we cannot, calculate the average, median, mode, anything, right?
Yeah, we can't calculate in
Yeah.
terms of.
So yeah. So that is the main difference between a categorical and a numerical data. Okay. So we will go into the detail, right? What is discrete data? What is continuous data? So let's take few examples, right? So what is a discrete data here? Right. So discrete data is basically countable. Okay. So you have numbers 1 to 100, basically integers, right? So it's countable, right? But if I ask you about the continuous data, right? So it's the continuous values, right? So it could be even in between 1 and 2, there are infinite values, right? Because you can have a lot of the values after a point as well, right? So let's say the first value could be 1.0001, right? So similarly, you can have infinite values between 1 and 2. So this is again a numerical data, but a form of continuous data. It's not countable. Okay, but this will represent a value because it's measured, right? If I'm saying 0.85, it has some measurement, right? 0.85 keeps like have some meaning, right? But it's a part of continuous data, so they'll be having. So the basic definition of continuous data is you will be having infinite numbers between two numbers. Any doubt or any confusion here about continuous data and discrete data?
No, good to go.
Okay, what about others?
But only one small note, like when it comes to height, there is a limit, right? Or after certain age, certain intervals of time, it will be fixed. It might not change or sometimes. So how can it be take when it comes to interview point of view?
Yeah, so as I mentioned, infinite, like it could be between two numbers. So let's say we have height as a 5 feet and 6 feet. Okay, these two are numbers, right? So you can have, let's say, our population of this world. Let's consider this as infinite. Okay, 7 billion peeps, right? So between 5 and 6, you can have n number of possibilities, right? And that are uncountable, right? It could be 5.1,
Yeah,
five point
yeah,
two,
got it,
five point
got it,
one.
got
Got it?
it. Yeah, I got it. Thank you.
Okay, great. Anyone else? Okay, only two knows. Are we good to go for the next part? Okay, great. Yeah. So again, now we will talk about the scales of measurement, right? So we have discussed the categorical data and the numerical data. But even inside categorical data and numerical data, we have different types as well, right? So first let's talk about the nominal category here, right? So these are the categories that is without the order. Okay. So can you let's say if I'm giving you male and female as a gender, right? So will you be like able to arrange them in the order? Let's keep it interactive. I want to hear yes or no. I can give you few more example if it is difficult for you. Let's say you know type of pet, right? Uh, you have dog, rat, fish, bird, cat, right? So can you order them? Is it possible to order them?
Order them in terms of alphabetical order we can do, but
No,
not
no,
in.
not the alphabetical order. With the quantity,
No.
right? So
Mm,
there's no way to like order them, right? So because all are pets, right? They are not having their individual
mm.
value,
Yes,
right?
yes.
All of them are falling under the pet category. So what again? These are the categories only. So inside the pet category, pet data set, you'll be having one category dog. You will be having one category cat, right? But ordering is not possible for all of them, right? Because they don't have that kind of statistic, right? Maybe like if you start talking about their height, age, then you can order, but it's not the categorical information about them, it's the numerical information about them, right? So these are our nominal variables. Okay, now let's talk about another scale of measurement in the categorical variable or categorical data, right? That is ordinal. Okay, again the same thing, but we can order them here. So let's say we have grades A, B, C, D, E, right? So now can you order the grades like which one? Because A is highest and E is like baddest, right? Yes or no? Nice, please speak. See, I mean, if we will not speak, right? For me, it's not a problem. I'll just finish the today's lecture and go away, right? But in future, you will face a problem if you're not able to understand what I'm trying to teach you, right? So better tell me yes or no, you are comfortable with it or not. Okay. So we are good to go here. So here in the ordinal, we'll be having categories only, but these things will be ordered, right? So let's say if we talk about rank, first, second, third, fourth, right? So people can say first is better, second is little bit like less better than first rank, right? Maybe it's based on the number, I mean the marks that he got, correct? And like, or we can talking about the hotness of chili, right? Hot, hotter, and hottest, right? So these kind of examples could be there in the ordinal category. So I think we are fine till here. If anyone have any doubt, please let me know. Okay, so now let's jump into the numerical section. This one is interesting. Okay, so see, you will have some doubt here, right? Okay, so please let me know. So here interval we talk about. So I'll give a very brief definition of it, right? So interval is basically ordered, measurable, but with no true zero. Okay, so there's a deep meaning, no true zero, right? So let's take example of temperature in Celsius, right? So if we are saying 0 degrees Celsius, it means because let's see what I mean from with no true zero here is if we are saying zero, zero can exist, but it will not be a true zero, right? Because zero has some significance. If we are talking about 0 degrees Celsius, it means 0 degrees Celsius temperature is there, right? Any doubt here? Vinay, is this your yes for doubt or
No, I understood.
okay? Great. Anyone else?
Can you give like another example other than temperature for interval?
Okay.
Is there
So
any?
let's talk about your exam scores, right? So here, even if you are getting zero, okay. So what does that zero mean? It is having some significance. It is not true zero, right? It means zero means you failed. Correct?
Yeah, fail itself has a value, right? In point of that, you're telling, right?
Yeah.
Okay.
Okay.
Perfect.
Similarly, we have one more category that is the ratio. It is again ordered measurable, but it has a true zero. Okay. So few examples are available on the screen. First is weight, right? If weight is zero, so can you even feel it? Zero means zero here, right? It will not exist. If the age of a person is zero, it means it's not born yet. Correct? Okay, can anyone come up with some examples for this particular category? I've given you two good examples, age and weight. I want to hear few from you, where the data will be having a true zero, right? Anyone? I can give you one more very good example. That is the number of children. Okay, so if I'm saying I have zero children, right? It means I don't have any, right? It's a true zero value. Have you understood what is the difference between a true zero and the no true zero?
Yeah, understood. Can you please, as you mentioned in weight and age, in terms of it, can you please explain once?
Correct. So I can give you a few more examples. Could be height as well. Like if it is zero, it means it does not exist, right?
Yes, like
Could
when
be
to
sales
consider
figures.
zero, when not to consider zero, when it has value or not. Bit like confusing stuff. So a little more detail in terms of ratio.
So you want few more examples for ratio, right?
Yes, yes, exactly.
Okay. So as I mentioned, age could be one of the examples. We have weight, we have height, right? And then we let's take example of sales as well. If I'm saying, let's say I'm a salesman and my sales is zero, right? So it is 2-0 only, right? I was not able to sell anything, correct? Income, let's say my income is zero. It means I don't have any income, correct? Years of education, if it is zero, right? I have not, I'm illiterate.
Yeah, got it.
Okay, cool. Yeah.
Can
So
like
now
time duration comes under a ratio? Like it could be true zero, right?
time duration, yes, but time on a clock with hands, right? Your clock can have true zero value.
No, like I'm talking about just the time duration, like zero
Yeah, time
second
duration
will pass.
obviously. If you have not spent any second or any minute on
Yeah.
any task, right, it will have a true zero. Okay,
Okay,
so I
got
was
it.
just sharing one more example of a clock, right? That falls under the interval category, right? A clock cannot have a true zero. Anywhere if you see, right, it will be having some value. Correct? I think all of you are confused. If you have any doubt, please ask me. It's a little confusing topic. Okay, so I've received from Prashant. He has not any doubt. Anyone else? Okay, great. Yeah. So okay, so we okay, like we have talked about statistics in brief only. Okay. So now let's talk about the type of statistics, right? So here we have talked about a lot of stuff, right? How to check the type of variable. We talked about a lot of use cases, right? How to organize, right? How to interpret, how to analyze the data set, right? So now these things falls in two different categories. So one is the descriptive statistics, right? And other one is the inferential statistics. So whatever we do, like organize, collect, right, interpret, analyze. So here we are doing just the descriptive analysis. We are basically summarizing the data set, right? What is there in the population? What is there in the sample set, right? So any statistics that we are giving about the data set falls under the descriptive category, right? But if we are using the data and making prediction out of it, right, then it will fall under the inferential statistic part. Any doubt here? Okay, no doubt, Rakesh. Okay, anyone else? What is like? If you have any confusion between different descriptive and inferential statistics, please let me know. Okay, cool. Let's go ahead then. Yeah. So now we have the next topic is the measures of central tendency. Okay, we will talk about this detail in the next session, right? But I want to give you some hint, right? What are the measures of central tendency? Okay, I think since childhood you must be hearing about mean, median, and mode, right? So can anyone explain what is mean? Right, I just want to know like how much you know about mean, median, and mode. Can anyone unmute yourself and tell me what is mean here?
Like
Yeah, please go ahead.
Mean is like average of all the values.
Okay, great.
like if we have a set of 7 digits or a set and sum of it by number of elements which present in that set.
Okay. And
Like
anyone can
sum
tell
of all
me
values and divided by total number of values. That's it.
what it represents basically? Why do we use it? Can anyone tell me? You tell me like mathematical formula of it, but can anyone tell me what it represents? What I like, how can we use this?
Average of total sum, like mid value indirectly almost.
Mhm.
Yeah.
Anyone else? Then give it a try. So see, let me explain, right? So measures of central tendency, what we are trying to do here. Here we are basically, trying to summarize a data set. Let's say you have several heights, right? Let's say we are talking about a particular, let's say we're talking about a class, right? Or employees in a particular zone or office, right? So I want to tell you the average height of that office or that class, right? So what I'm trying to do here is I'm trying to summarize it, right? So if I'm telling you the average height of that group, class, or office is 6 feet, so most of them falls under falls almost near the 6 feet category, right? Until unless we have a very high variance. Okay, you guys, I mean, very again, we are using another term set that may like we'll be discussing in the next class, right? But let's say until unless we have some outliers, that we have a very tall person that is affecting our mean, right? Otherwise, almost everyone will fall near to this category, right? So let's say if we are talking about average height of section, sorry, class 5th and class 10th, right? So with that average height, you will be able to know the difference, right? Maybe in class 5th, average height will be 3 feet, and in class 10th, average will height will be 5.5 feet, right? So now you know there's a difference of 2.5 feet between these two classes, right? So with the measures of central tendency, we are basically trying to summarize the data efficiently. Okay. And as we have compared the height of two classes, we try to compare different data sets using these things, right? You get it right? Because when I compared the mean of two different classes, right? So that's how we use it for different use cases as well. Okay. Yeah. Any doubt here so far?
No.
Good. And again, it helps us in decision making as well. As I told you, right? The average height for class 5th is 3 feet, and average height for class 10th is 5.5 feet, right? So now you know, let's say you want to make a basketball team, and both the classes are talented in basketball, but you need tall players for basketball, right? Or you may need tall players for scoring, and small players for passing and dodging each other, dodging the other players, right? So you can make your team using this statistics, right, that you have, right? And again, it helps you to see different type of data distribution. Okay. Now let's talk about other two statistics as well. That is median and mode. Okay. So what is median? Anyone can tell me?
Like the average of first and last element in a set, like by two, whenever we do like that, and we should keep those in ascending order to make a particular prediction, like a min and max by two in that way.
Median, no.
Minimum value and maximum value by two.
That's not the right answer. Anyone wanna give it a try? What is median?
Median is a middle value of the data, like when it is arranged in the ascending order.
Very nice. And if it is arranged in descending order, so again the answer will be correct or wrong?
I think it will be same, right? Like
Yeah,
it
it will
is
be
arranged
same.
in the ascending order.
Correct. Okay. Anyone else? If you have a different definition about this topic. No one? Okay. So yeah. So the last example was right. So when you arrange a data, right, in the order, right? So when we use median, let me tell you that, right? So I've given you examples, right? When the particular, entity, right, or particular, so let's take example of class only, right? You have like you want to calculate the average height from your class, right? But the problem is you have some outliers. Some students, right, in third class only, there are 5.5 feet, right? So somehow these people will impact your average, right? So, but if you arrange it in an order, all your heights, and take the median, the center value of it, right? So your statistic, right? The measure of central tendency is not affected by the outliers, like the 5.5 feet guys. Any doubt here?
No, no, but based on the length of that things, maybe based on order and even like if it is three is different, if it is four element is different, right? In terms of
Here what I'm trying to say. Okay, so I just want to see what is the average height in a class, right? So here we are talking about the same thing only. It's basically the measure of central tendency, right? We are trying to summarize the height of the class. But let's say out of those 30 students, five are very tall, right? Most of the class students are under 3 feet or like close to 3 feet, 3.1, 3.2, 3.5 at max, right? But because of those five tall students that are above five, your average height will get impacted. right? Maybe because of that, your average height is coming as 4 feet. So you'll be having the biased data, right? So that can give you a wrong measure of central tendency. So that's how median help us, right? So median is, robust to the outliers. It because the outliers will come at the end, right? So if you try to find out middle point of it, if you arrange all the heights in order, you will land on a very nice value, or kind of very nice central measure of central tendency, right? Because your central middle value is not impacted by the outlier, right? Here, because we are not adding all of them and taking the average. Got it? But the problem could be, if you have a lot of outliers, right? As I mentioned, you have a lot of tall guys and you have a lot of varied values like 1 2 3 4 5 6, like this number, right? Even this can give you, if you count it like 1 to 50, and I want to ask what is the middle of it, right? So it could be either 25, right, or 24. Agree? So it's almost the center of it, of these values. Anyone, any confusion? Okay, let me add few more things here. Okay, let's say we have numbers from 1 to 50, but I'm adding 5 more 50s at the end, 50 50 50. Okay, so now we have, let's say, 55 values here. Okay, so what will be my median here? Can anyone tell me? No.
Sorry, Arshu, I missed it.
Okay, so I just want you to calculate. I have given an example, right? We have numbers from 1 to 50. So my median either could be 24, 25, 26, right? But if I am adding few more 50s at the end, let's say 5 more 50. So now you have one numbers from 1 to 50 and 5 more 50 are there. 50, 50, 50 at the end, right? So now how your median will be impacted by, because of these 5 additional 50. Your median will shift, right? Because we try to find out the middle of your series, right? So here your median will be 28. But now you understood, because of these 5 outliers, my median, the measure of central tendency, is not moving that much. It's still close to 25, right? But if you add all these numbers and take the average, your mean value will shift by a very big margin. You're getting my point? Anyone, please tell me if you have a confusion. Rakesh, that's not how we calculate the median here. I told you, like, we arrange all the data points in the ascending order, then we see the middle part of it, right? So let's say if you have, okay, now there's a catch, right? If you have odd numbers, right? Let's say you have 5 numbers, you will be able to find the middle part of it, right? So let's say you have 50, 60, 70, 80, and 90, right? So what is the median here? The middle value is 70. So we will call, okay, the median is 70. But if you have numbers 50, 60, 70, 80, 90, and 100, now you have 6 numbers, right? It's even. So what you will do, you will take middle two values, right? So what are those middle two values? 70 and 80. You will take both 70 and 80 and take the average of both of them. So your median will be somewhere around 75. Okay, understood? If you have any doubt, I can explain again. Okay, so Justin have a doubt here. Yeah. Okay, so first of all, like, what is mean? Let's start from the scratch, right? You can also, try it on pen and paper, or you can use your phone. Okay. Now try to tell me, okay, I'm giving you 5 numbers. Please note it down, right? Or I can paste it in chat as well, right? 50, 60, 70, 80. We have 50, 60, 70, 80, and 90. Can you please tell me what is the average of these five numbers? So it is 70. Like, so how will you calculate the average? You will sum up all these numbers and divide by 5, right? Okay, so now what I was trying to tell you, okay, if I'm giving you, let's say, three more 90s, okay, so now what you will have, it will look like this. Let me paste it in the chat. Okay, not nine, let's say not 19, okay, let's add 900 then, to 900. Okay, so now can anyone tell me what is the average of all these 6 7 numbers? Calculate quickly. Right. Okay. So now you can see, because of these two additional number, your mean shifted a lot, right? So let's say here we are talking about uh, some score. Okay, could be anything. Okay. So in general the score was around 50, 60, 70, 80, 90, right? But because of these two guys, 900, right? Your average shifted towards a very big number, correct? So now if I'm asking you what is the average score for this sample, you will say 307, right? But this is not the right average, correct? So this is getting impacted by the outliers here, the bigger values, okay? But let's say if I'm asking you to calculate the mean of this data set, right? So what will be the, sorry, not mean, the median of this data set, what will be the median? Can anyone tell me? I've told you how to calculate the mean. Yep. So how we calculate the median here? We choose it's already arranged in the ascending order, right? So here we choose the middle value of it, right? So what is the middle value here? It's 80, correct? So your median is not getting impacted by your outliers, right? So initially, like if I just had only five numbers, 50 to 90, the mean was 70, right? So our median is still close to our actual mean when we don't have the outliers, right? So that's why I was saying median is a better option when you have the outliers in your data set or the extreme values, correct? Okay. Anyone? Any doubt here? Great. Okay. So can we move to the next part, that is mode? Great. Okay. So how we calculate mode? That is our next topic, or the next measure of central tendency, right? So mode is nothing but, if you have a very frequent number in your data set, right? If it is coming again and again, okay, it's kind of a measure of central tendency only, right? But I want to hear it from you first, right? What do you think of mode it is? Like, because we have learned like all these things in our childhood, right? So I just want to, know what is the idea of mode in your mind. Can anyone unmute yourself and tell me?
And generally, the data which repeatedly appears, like any data, it might be which occurs most. A few data might be repeated, but which has highest repetition, will consider that as a model.
Correct. So yeah, what our, like from our data set, mode could, like there are many types of mode, right? So your data could be unimodal, bimodal, or multimodal. So by unimodal, I mean, so you will be having only one number that will be frequently coming in a data set. Let's take example. We have 2, 3, 4, 4, 5, 6, 7. Okay. So in this example, 4 is coming twice, right? So if I ask you what is the mode of your data set, so you will say 4. Okay, because 4 is coming twice, right? Let's take one more example. You have example like 1, 2, 2, 3, 4, 4, 5, 6. So here in this example, 2 is coming twice and 4 is coming twice. So in this case, our data is bimodal and we have two modes, 2 and 4. Okay. Similarly, you'll be having multimodal as well, right? Where multiple values will be coming in the similar frequency. Okay. Any confusion so far? Nice. Okay. Now I have one question. Okay. Can anyone tell me when can we use mode? In what scenario? Any example that anyone can give me? We learned, I can give you a hint. We learned about two special, not special, two type of data, categorical data and numerical data. Now think of where can we use mean, median, and mode. I just want you to come up with example for mode. All of you know where can we use mean and median, right? But where can we use mode? No, Rakesh, number of items order is not mode, right? So one of the example could be right, what was a basket size, right? So so the mode can be like the basket. Most of the time, the basket size, the number of items, 5 were there, right? So this could be one of the example of the mode, but generally we use it for the categorical, right, information, right? We want to analyze, like we can take example of any categorical data. Okay, let's take example of popular shirt size. Okay, so which size of the shirt is selling more, small, medium, or large? So this is kind of giving you some insight, right? If you're selling medium in the large quantity, so what is the mode here? It'll be medium, right? And you can take example of color preferences, most sold product, right? These kind of categorical information you can analyze. Any doubts so far here? I guess no. And in the interest of time, let's move to the next topic. Okay, so that is the measures of dispersion. Okay, so when I take the examples of the mean, right, I tell you, like I told you one thing, right? If the variance is high, right, so my class can have, so as I like told you, I have my class average is 6 feet, but the variance is very high. It means your values are, the ages in your, the height in your class are not, close to the 6, right? Maybe you will be having a 5 feet guy as well, or a 7 feet guy, right? Because of the high variance, right? Can anyone tell me about what is variance here, like based on the information that I provided? Okay, let it be. Like it's a difficult topic. Let me explain, right? So, with the help of measures of dispersion, right, we are trying to calculate the spread of your data set, right? So let's say you median is your center, right? We like learned about the measures of central tendency. Now you know what is the center, right? Now, if you want to know how far or what is the spread of your data set around your mean, right? So, as I told you, the minimum height could be 5 feet, but your central measures of central tendency was the mean was 6 feet. So it means still there's a gap of 1 feet between 5 and 6. So on the left side of the graph, there's a spread of 1 feet, right? There are a lot of people that exist between these two values. You're getting my point? So with these things, okay, when I know, Hello, Vinay, do you have any doubt? Okay, great. Yeah. So all of you understood what is spread here? Please answer yes or no. What is spread here? All of you understood? So I'll explain one more time. So with the help of measures of dispersion, we are trying to see how far are the other values from my measure of central tendency. Those were mean, median, and mode. Okay. If I'm saying my measure of dispersion is very high, it means there are a lot of values that are far from my median or mean, right? As I took example of height, I'm saying average height of the class is 6 feet, but my measure of dispersion is very high. It means there are a lot of people with other ages, like it could be 5, 4, or maybe on the higher side 7 or 8, right? But ultimately, the average is coming out 6, right? Because it was the center. Okay, but if the measure of dispersion is very low, that's a very good thing. It means most of the height of students in the class or in the office was close to our measure of central tendency. Any doubt here so far? No? Okay, I'm considering this as yes. You don't have any doubt. Okay. Yeah. So, like, how these measures of dispersion are helping us, right? So, first of all, like, it's helping us, to understand the data variability, right? As I like mentioned, right, if it is very high, and if the measure of dispersion is very high, and we want to order t-shirts based on height for a particular class, right? So I gave you the average, okay? The average height is 6 feet. Order t-shirts according to that, right? So then what about the students with more height and the less height, right? Because your measure of dispersion was telling you have very large spread, right? So it means for the smaller size guys, the t-shirts are gonna be very loose, and for the higher height guys, the t-shirts are gonna be very tight. So you are not ordering the correct number of t-shirt, the correct size of t-shirt, right? So this basically, like is helping you to mitigate that risk, right, of ordering wrong sizes, right? So that's how we try to get as less measure dispersion as possible while trying to order these things, right? Okay, or we can try, if you want to solve this problem, we can try to divide different sets, right? Okay, so let's talk about one of the simple measure of dispersion, that is basically the range, right? So what is the range here? Like what? It's very simple example of a measure of dispersion, right? So it's the range. So range is nothing but is the difference between the maximum value and the minimum value, right? So let's say if I'm standing at the minimum value, right? So I can say I can still have, okay, let's take a very simple example. We have values like 10, 20, 30, 40, and 50. Okay. So range here will be the difference of your maximum value and the minimum value, right? So in this example, the maximum value was 50 and the minimum value was 10, right? So what will be the value of range for me here? It is 50 minus 10, 40. Okay. Now, like when can we use this range, right? Because like let's say you want to give quick measure of variability in your data set, you can say the range for my data set is 40. So let's say you are standing at some value, let's say it is 10. Now, if I'm asking you how far can be your next point, so what you will do, you will just randomly add 10 plus 40. So the data that can go far as 50. Okay. All right. Any confusion here? Okay. So what is the problem with the like range, right? So it is very sensitive to the outlier. Let's say you have the last value of your data set is very, very large, right? So this will give you a very absurd value for your range, right? So this is not the very good measure of dispersion. We have very you know nice or very what do you say here, good measure, right? That is the most important one, is the variance, right? So variance is nothing but the average squared distance from the mean. Okay. Uh, so we will talk about, okay, let me give you the name of all the measures of dispersion, and we will talk about all these measures of dispersion in detail in our next class. Okay. Or maybe it could be, or you can consider this as a homework, and you can, read about it. Okay. So we will be discussing in our next class, we'll be discussing about variance, standard deviation. Okay, so these two are the very important or the crucial topics in statistic, right? Most of the time, like when we talk about all the big things in statistics, we'll be dealing with these two values, variance and standard deviation. So that's why I'm gonna take some time for these two particular concepts and try to discuss them in detail, right? So let's move to the next part. Again, it's a interactive activity, right? So, I think we have already discussed about the data classification, right? If I, ask you to give me an example of nominal, ordinal, interval, ratio kind of category, will you able to give me? You can answer it yes or no, otherwise we can discuss. I want everyone to be comfortable with all these four categories. Do you know what is nominal, ordinal, interval, or ratio data? Rakesh, Vinay, Prashant. Great. Okay. Okay, so that's the end of the class for today. I just want to take feedback from all of you. Okay, so was the pace was very high for you, like, or you wanted to, want me to slow down, try to take more examples, right? You can tell me, right, so that I can, come prepare for the next class. What kind of, you know, pace you want? You want more examples? You want more visuals? You can tell me. You can unmute yourself and then tell me, because that was the introduction class. I wanted to give you the hint about the statistics, right? Okay, Rakesh, I didn't get it. No go speed. You mean you want me to go fast?
Actually, I feel it's good. Nothing much more need to be updated, but only one thing, more examples. These are good things, but just if you had two, three more examples, it will be more added advantage for us to remember, or else to explain in terms of to anyone. It would be more useful.
Sure. But I think I was trying to take as many examples as possible while explaining, right?
Yeah, you did the best. You did the best. Just normally, I'm telling.
Yeah, I understood. Great, great. Thank you for the feedback. Anyone else like that? I mean, that you feel that could have been better? Okay, so this is the homework for you guys. Okay, it'll be great if you do this. Okay, so find a real world data set and identify its population, sample, and type of the data. Okay, please note it down. I want all of you to show me this in the next class. Okay, and research one application of statistics in your field of interest. Okay, please note it down. We'll close the lecture. You can take the screenshot. It'll be easy, faster for you.
Thank you, Rishabh.
Okay, great. Thank you guys. It was a nice session, right? Please start like speaking and try to keep it more interactive. I'll feel very happy, right? I want you to be, expert in the statistics. Sure, Ashish. I'll use whiteboard most of the time when we have to, explain, right? Yeah. Good day, everyone. Thank you. Thank you for joining. Okay, see you in the next class. Thank you. Bye bye.